welcome to the Romo group. We're going to give you a quick tour through some of the instruments and things that we have in the lab, and of course the lab itself. Hopefully we'll meet a few folks along the way, grad students and postdocs that are working in my group currently. Thanks to Nate, who's holding the camera. So come on in. Let me show you guys our lab here. Romo lab, C258R. Let's walk through here. As you can see, we have a separate office space from a lab space. This was a very nice feature, I guess, when I moved from Texas A&M about 6 years ago, was to have a separate office space, which of course from a safety perspective is very important. But we also have room here for, I guess, a total of about 12 researchers. Have a couch for those who need a break. Over here, everybody has their own computer, monitor, so forth, in order to access literature and whatever's needed. And over here we have a little kitchenette, you guys to heat up your food, store your food, refrigerator, and so forth. All right, let's go into the lab here. Now we're going to meet with Dr. Srikumar Vellalov. He is going to tell us about chiral HPLC, so come on over. Of course, as we go through, you can see different parts of the lab. But this is Dr. Vellalov. Go ahead.
So this is our chiral HPLC system, which is attached to the column changer, using which you can screen 5 different chiral columns for your sample to separate the racemic compound and eventually to determine the enantiomeric excess.
Okay, very good. Yeah, so this is an instrument for some of our synthetic methodology projects. Of course, we're very interested in knowing what the enantiomeric ratio of these asymmetric reactions that we're doing, and Srikumar keeps this thing humming so that we can quickly determine, as he mentioned, our enantiomeric ratios. So if you come over here, we can see the rest of the lab. We're going to have some separate video to show you some of these instruments, but right now let's just kind of get an overview of the whole lab. And the way these 8-foot hoods are set up are quite nice in terms of having different bays, but the fact that they're 8-foot, of course, is nice. So a grad student and a postdoc will each have their own hood, and sometimes undergrads will work in those hoods with the students, or we also have, at least right now, a couple of hoods that are set aside for undergrads. So you can kind of get a sense of kind of the overall size of the lab. There's a total of 3 bays and 4 hoods at each bay. And I'll show you one nice piece of equipment, of course, that makes solvent stills obsolete now. This is a nice system that allows us to dry our solvents. This comes out of UC Irvine, actually. It's first, I think, developed there. But this is passing through basic alumina to dry solvents. It doesn't deoxygenate, so usually we're doing that separately, but it does dry them quite well. And we actually have a Carl Fisher titrator that allows us to determine how dry these solvents actually are. Okay, so let's walk over to talk to Evan Woods, who's going to tell us about the MPLC systems that we have in the Romo group. So why don't you guys just come over here. And we actually have 2 systems, so he's going to talk about this one and move on to the next one. Please, Evan, take over.
Dr. Romo. So this is one of our MPLCs. This is a medium pressure liquid chromatography system. It's an automated way of running flash columns. And so this one is the older system, and it contains just a UV detector. So if your compound is UV active, you'll be able to see that coming off of the column. We also have a newer system over here, which has both the UV detector as well as an LSD detector, which allows us to detect compounds that are not UV active. So if there's anything coming off the column, we will be able to see it with the LSD.
All right, so we're going to talk to Patrick Suter. Earlier I said it wrong, but here I'm saying it correctly. But this is Patrick, and he's going to tell us about the flow reactor that he uses quite often.
Yeah, so what's really cool about this flow reactor, it's one of the more advanced state-of-the-art models. It's a couple different housing elements within it. One of the big elements that we have is this UV reactor, which we can do photochemical type reactions in flow. as well as a very pretty cool instrument called the tube-to-tube reactor, where we can accurately and efficiently deliver gas into solution when we're doing things in flow. But what's really nice about this model, we have a built-in computer module which helps us fine-tune the different parameters that we can test when setting up a flow experiment. And on this nice digital touchscreen display, we can go through and accurately go about changing those parameters. And because it is a built-in computer, we can also save those parameters for future uses when we divertize different substrates when looking at different flow movements.
Okay, so you've heard about the flow reactor. Why don't we move over here now, where we're going to hear a little bit about the thin layer chromatography mass spec system, mass spectrometry system. And yeah, why don't you guys come over and introduce Sigrid and Rahel. Sigrid's a grad student and Rahel's an undergrad. And a perfect opportunity now, because Sigrid is actually training Rahel how to use this instrument, so you can kind of see the whole process of how this TLCMS is quite useful for our research. So take it away, Sigrid.
So we just took a TLC of one of the reactions that Rahel was doing. So I don't know if you see, but this compound is UV active, so we were able to mark where the spots were for our product. So since we know where our product is, or at least are fairly confident, we can use this instrument, which is called a TLCMS, which will allow us to, it's another tool to confirm that we have the products we think that we do. So it allows us to take the mass of whatever the spot is on our TLC plate. So when we go to use this instrument, as you can see, it has a laser that allows you to position the plate where the spot is in line with the laser. And so you just, it's already on now, but if you were to turn it on, you just push play here and let it warm up for a bit. So then when we're ready to measure or take an MS of our TLC plate, you just push this blue button up here. Go ahead and push the button. It usually takes a few seconds. So right now it's basically extracting from that spot. That we have a peak showing up. So then we can click on data analysis and click on that peak. Try to stay close to the middle. And yeah, from there you can see that we have the mass that we were expecting to have. So again, it's another really great tool for helping us be confident in what we are getting out of our reactions.
Okay, let me now show you an overflow lab. It's basically a lab where we have more equipment for the lab, where we kind of run out of space here. But I mean, come on over and I'll show it to you. As you can see, it's just the lab directly across from us. Okay, and here we have Jacqueline. Jacqueline is doing some photochemistry, so she's going to tell you a little bit about her photochemical setup here.
Hello everyone, so this is the photo box. We have this key to make sure that it's locked whenever we are running some photochemistry. Inside here we have two mercury lamps. So to the left we have a 450 mercury lamp with its immersion oil, and then to the right we have a smaller one with 4.5 watts. And see our glassware that we typically use when we run big scales. So if we close this, once our apparatus is set there, we can turn on our power supply and our safety controller, which helps us with our temperature and our water flow.
All right, so you just heard about the photochemical reactor. Now we're going to move over to talk to Nate Truax here, who's going to tell you about our microwave system. Nate, take it away.
So here's our microwave. It's a CEM Discover, and our group finds this extremely useful because it has this Explorer arm on it, which allows us to do multiple reactors at a time. So what this arm does, this little robot, it can come down, pick up a microwave vial, and drop it down into the reactor itself. This is pretty nice. We do a Pianketelle rearrangement, and we do 24 to 48 vials at a time. And so this can just, in serial, add them in overnight. We don't have to sit here and babysit, and we can get through all of our reactions.
Okay, that pretty much concludes the tour of the Romo Group lab here, and I just want to thank you guys for listening in and watching. And the other thing is, make sure that you realize that this lab is sort of a reflection of all the labs in this Baylor Sciences building. As you saw, hopefully there are a number of great labs here to work in, great mentors to work with. So I would encourage you guys to, of course, join us here at Baylor in Waco, Texas, and come try out some of these great facilities we have here. So let's go ahead and walk out and all right. Thanks for coming, guys. See you later. Hope to see you soon.